We now know that the post is sufficiently strong. However, we also need to check the capacity of the embedded material to make sure the post will not tip over or pull out. So we'll look for IBC section 1807.3.2.2, equation 18-2, gives a governing equation for the depth of embedment required to resist lateral loads, where lateral constraint is provided at the ground surface. And I've drawn this all out in a diagram here for you, and that D required is in blue at the bottom. In this case, P is our force at height h, or that's just going to equal mg, P times h. S3 is our allowable bearing pressure of the embedment material, and B is the width of our embedment footing. S3 we read from table 1806.2 and can then multiply by 2 according to section 1806.3.4 because of the isolated pull factor. Using these values, we can calculate our required embedment depth D and compare this to our actual embedment depth of 40 centimeters. And I've drawn this diagram out here to also give you a little more perspective if we wanted to draw a free body diagram of what is happening here as well to have another mode of calculating that D required. We have our fill and we have our point of rotation of the block, and we'll want to be checking, if we're checking each component, we'll want to be checking first that the post isn't rotating in the block about this point, and then again that the block and post, once we can determine that it's one singular object, we want to make sure that that isn't rotating within the fill. And we do this because the actual blockout is going to be structural concrete. It's going to be stiffer and stronger than the fill material. So because the post has a smaller diameter and is going to be exerting more pressure because of that, we put this blockout, and then the blockout is going to have a larger surface area to distribute force onto the fill, which is less stiff and less strong of a material than the structural concrete. And here are some example values from table 1806.2. We can use the values from this table come from embedment into the ground, so we have to do a little bit of adapting to work for our situation, but we can take the value for, presumably take the value for hard rock because we are using concrete, multiply by that too because of the isolated pull factor, and then finally multiply by our depth to get because this S value is a per foot value, so we want to multiply by our depth to get the S3 value.